Well, thank you. I just want to really quickly thank the organizers for this conference. I'm just blown away by the attendance and the talks so far. So that I'm up here giving a talk among these greats I'm very pleased to be here. So again, my name is Clair Sullivan, and I'm on the data science team in machine learning at GitHub. And just we're now getting to the audience participation portion of the program. So if you could quickly just please raise your hand if you know what GitHub is. Good. Okay. All right. Now, second, raise your hand if you use GitHub. Yes. Okay. So there's a lot of stuff that I don't have to talk about because you are already experts in it. But let's just do a quick thing here, a little bit of fun. If you attended our big industry event called Universe in October, you're not eligible for this part. But I want to talk about GitHub by the numbers. And when we start talking about data that GitHub might have access to, what might that mean? So quickly here, we're going to start shouting out numbers. How many repositories do you think exist on GitHub? Just start shouting numbers. Infinity. For the sake of my job, I'm glad that's not true. Okay, so I'm hearing numbers in the millions. I heard 100 million. Billion? No, but 67 million as of October. These numbers are, I graciously borrowed them from our fearless leader, our CEO, Chris. And, okay, so 67 million. How many monthly visitors might we have? Unique monthly visitors. Shout them out. 100? 200 million? Okay, you've spanned the space there nicely.
Like in the
billions? Okay. Sorry to disappoint. It's only 53 million in a month. Unique users. Okay. Here's a fun one. How many commits did we have in the past year? A billion? I got a billion? 100 million? 500 million? Okay, we're doing better now. We got 1.5 billion commits in 1 year. Okay, so that's pretty cool. But now we have the pièce de résistance. How much code in bytes do we have on GitHub? Including, yes, we just think about, we have people who like to do illicit things, housing movies and violating copyright laws, but you know, how many bytes do you think? Just start shouting them out. 26 petabytes. Wait, what was the one over here? A 7. Okay. At least. Okay, let me give you the answer. The answer is we have half a petabyte of data. Okay, so we have access to this huge amount of data that's all open source data. And the question is, what can we do with that? What should we do with that? I mean, not everything in machine learning should be done just because it can be done, right? So what is our goal at GitHub? And before I go there, I just want to talk about how this talk is structured. Because if you're somebody who likes to think left to right, as we're taught to do in some of the more romantic languages, you might see that we're going to wrap up at the end. But really, when we start thinking about designing things for machine learning, we should think about the end first. What is the end that we're trying to get to? Before we do any coding, before we come up with any models, what is that end point? And we're going to actually hit on that up here in the beginning. But really, if you're somebody who wants to know exactly where the talk starts and stops, start here and go that way, okay? But I just think it's fun to have slides that go backwards. Okay, so what is our goal at GitHub to do with that data? Obviously, GitHub is a very big proponent of open source software development. The catch with open source, as most of you know in this room, is that a lot of us work on it in our free time. Even those that don't work on it, they're small teams. You'd probably be surprised to learn how many people are the actual big maintainers of packages like NumPy within Python. It's only like 6. 6 people maintain all of NumPy. Okay, that's a crazy low number. They need help. And by the way, that's not their main job. That's not their day job. So what we want to do is we want to find a way to help developers. We want to help developers find other developers who can help them. We want to help developers find things that they can contribute on and that they can work on. So we talk about code finding people. It's really more than just code because GitHub houses all kinds of things that aren't code. You can host books on GitHub and you know, there's the people with their movies and whatnot. But we want to help somehow developers find projects and projects find developers. So we did this thing that that we released at our big universe thing in October, and if you weren't paying strict attention, you might not have seen it happen. But this is what we did. It was called Repository Recommendations. So if you were looking at your main feed on GitHub, mid-October, we flipped the switch on it, there was this new tab that appeared called Discover Repositories. And what Discover Repositories was about was how can we start getting other repositories in front of you that might benefit from your help. Or maybe you're a new coder and you're looking for other repositories that you could contribute to and learn from. So it was all about creating personalized recommendations to put in front of our users that would help users find projects and projects find users. So I just quickly went through and grabbed what my recommended repositories were for the other day. These things update themselves once a day. And I can see if, TensorFlow, that would make sense for somebody in ML, and I can see, a handful of other things. We've got Electron, building desktop apps, things like this. Interestingly enough, though, I actually have an image of what my repository recommendations were back last October. And prior to my work at GitHub, I hired on in August, but I was doing a lot of work in the GIS community and satellite imagery and all of this stuff. So you can actually go through, this side here is my October recommendations, and there's a lot of different GIS things there. So it's really cool because it dynamically is finding out what I'm working on and interested in at the time, and we're recommending those things out relevant to what you're working on now. Okay, that's cool. Let's talk, though, a little bit about machine learning. This was something, obviously, that was enabled by machine learning. Many of you will recognize it as the standard recommender engine that's used in ML. But let's talk about, from a broader perspective, some of the ethics around machine learning. As an open source entity, GitHub cares a great deal about privacy, obviously. So we want to do things when we create tools in ML, not just at GitHub, but just as a community. We want to think about maybe 3 things here. Do no harm. Okay, we all have been getting the GDPR emails. Obviously, that's very rooted in privacy. So, strange enough, GitHub users care about privacy just like users of other sites. So on GitHub, we have users that are hidden because they don't want people just going out and finding them. We have repositories that are private. So what we wanted to do was we didn't want to release those to the public. We're not exposing private repos and hidden users on our tool here. So then we want to talk about doing good, this idea of, helping developers find projects and projects find developers. We want to make sure that what we're putting in front of them are things that will actually connect those two together. And then we make good on those things. So let's get a little into recommender engines. And this is a bit more geared towards the people who are coming new to ML. And I'm going to start with an example here. And I'm going to start with an example that's kind of like Netflix. There was the Netflix prize a few years ago where they, let's come up with better recommendations for what movies are you going to watch. So I have my own personal Netflix here, and I'm going to take a set of 5 users. So you've got myself over here, and then we've got Neil deGrasse Tyson, and I've got Tom Brady, and I've got Barack and Michelle Obama. So here's our user set. Okay, and I'm coming up with some fictitious ideas about what movies I think we all might like to watch. So we've got Star Wars Episode 4, and it seems that Neil deGrasse Tyson and I both like that movie, which is cool. Then we got Star Wars Episode 2, which I didn't care for because it was really bad, but Tom Brady might have liked, Okay, then Star Trek II, Wrath of Khan, arguably one of the greatest movies ever made, and we all loved it, so that makes sense. Then I started hitting some Academy Award winners, so I've got Argo in here, some of us liked that. Some of us liked some of the more emotional romantic movies, Shape of Water, Sense and Sensibility. Okay, that's all well and good. I can start coming up with patterns on this, though. Like, for instance, Neil deGrasse Tyson and I like space movies. Okay, so that makes sense. Maybe Neil deGrasse Tyson and I are similar. Barack and Michelle Obama, it would make sense that they watch the same movies and maybe like the same movies because they have a relationship. So we've got relationships between users, so we've got relationships that go this way, but then the movies themselves also have relationships for, I've got the sci-fi stuff at the top. I should have included Harry Potter, I don't know why I didn't. Okay, then I've got some action stuff and I've got some romantic stuff. Now the question is, what happens when I bring in a new movie? Okay, so let's say I bring in The Hurt Locker. Who on my list here might like The Hurt Locker? Who do I want to suggest that to? Okay, so I could maybe think about, well, that's an action movie, so maybe the people who liked Argo like that. but it's also an Academy Award winner, so maybe the people who like the Academy Award winner movies are going to like that one. So that's the whole point of recommender engines, is how do I find similarities among users and among movies, or topics, or whatever, such that I can recommend to you something that might be something you would be interested or care about. Okay, so let's get into making the sausage of repository recommendations. When we sat down and we designed this thing, the question was, okay, we want to be able to put code in front of people. We want to put repos in front of people that would benefit from having their involvement, that would somehow be of interest to them. How are we going to do that? What kind of things do we care about? Like, I don't want to put, I don't want to take some garbage repository that's like really bad and put it in front of you just because it's Python. You're not going to want to interact with that as a user. So this is that starting at the back and working your way to the front idea. It matters that the repositories that we put in front of you on Discover Repositories are good, okay? So, and we also want these recommendations to be personalized, but they don't have to be. I'll talk about that in a second. So the idea, how we've done this, is we look at what things do you view as a user. There's all kinds of ways you can interact with a repository. You could follow, or you could watch it, you could star it. Maybe you're following other users on GitHub. But all of those bits of information help us to be able to make these personalized recommendations. We're going to then take all of those repositories that we have, those 67 million repositories, we're going to score them somehow. Okay, and I'm going to talk about how we do that here. And then we're going to take these scores and we're going to give you this list. And it's actually an infinite scrolling list, not truly infinite, but we'll call it infinite in quotes, scrolling list of repositories that we recommend to you. So let's look at the data that we actually use. And I should have actually put this at the top instead of the bottom, but I just want to reiterate how important privacy is to us and that your privacy matters, and privacy online should matter to everybody. Okay, but the 5 key elements that we used when we made these repository recommendations, first, the quality of the repository. Now that one, if I say how good is a repo, everybody's going to be like, ooh, this is going to get, this is kind of like Vim versus Emacs or something like that. You just don't go there, right? We're going to go there. Okay, so then we look at which repositories did you star and which ones did you watch. Which ones were starred and watched by the people you follow. So we have to know who you follow, which repos they star and watch. But what if we have a user who's completely brand new to the site? They have no history on the site. They're not starring and watching. They just created their account. We want to help them too. And so we have what we call the fallback model, where we can still make recommendations to people. They're not going to be as good, but we look at which repositories are trending and which are popular. Trending, all of a sudden we went from having 1,000 stars to 1,000,000 stars in a week. Okay, that's trending, right? Popular, which repos have the most stars and the most watches on our site? So that's how we serve up recommendations to our completely brand new users. But as they grow and they evolve in their use of GitHub, we can start providing more personalized recommendations. So we can do both. Okay, here we go. Quality of the repository. We actually use over 30 metrics to evaluate that, and we weight those metrics. So we've gone through these 30 metrics, and we've used a random forest model. We're going to talk about why a random forest model, not from a technical perspective, but at the very end. And it turned out when we did that, there were just 2 factors that were dominant here. And they seem silly. Does the repository have a README? I mean, we didn't even get into the nitty-gritty. Like, if you even just had a README that said README, okay, you're getting credit for it. Okay. Obviously, if you want to have users who can come on and help you with issues that you might have with your code, you want a little bit more than that in your README. Okay. But that was one of the most dominant ones in our model, was does it have a README? All right, the next one, how responsive is the repository? Okay. So let's say I'm a new user. Maybe I'm a student. We have over 1.3 million student accounts on the site. So I'm a student and I want to really start establishing my credibility in a subject area. Okay, I want to find what's that first issue that I could really help with. Okay, I find the issue, or I found bug in somebody's code, or I found something that would be a really good feature to have to their code. I'm going to create my pull request, right? Or I'm going to create an issue on the repo. I don't want that issue to just sit there for like a year and have nobody respond to it. Who's going to do that? Nobody wants that. And so what we want to look at is how are different measures of responsiveness, how much do they matter? And it turns out we actually did a survey of our open source community, and responsiveness was the #1 thing that they said that they wanted. They want repositories to work on that are responsive to what they say. So just repository responsiveness was a huge study for us. We look at 12 different metrics for responsiveness. And these are just some of the ones that are really obvious. The median time from opening a PR to its first review. Okay, again, I'm going to write a bunch of code, and it's going to go up in a PR, and then 3 months later, somebody says, yeah, you've got a typo in line 25. Okay, not cool. Median amount of time from PR open to merge or close. So I've written this code, it's gone through review, it's going to get merged or it's going to get closed, but you don't want that to languish on like 5 years. Median time from opening an issue to receiving its first comment, same idea. Number of comments per issue. Now this is a dodgy one here, okay? So I create an issue, people can comment back on it, and you should have some comments. You want to hear that people are discussing what you said. But maybe you shouldn't have too many comments, because we don't want abusive things happening on our site. Somebody comes back, oh, well, you're dumber than a stick for thinking this one, you should go delete your account. No, we don't want that. But abusive behaviors, and you've seen it online all the time, they really, once it's like an avalanche. Once it builds up some steam, it really gets going. So maybe too many comments is a bad sign. And then the last thing, which was a really interesting one to us, was looking at the ratio of opened to merged and opened to closed PRs. And why might that matter? Well, let's say I'm Node.js or TensorFlow or something like this, and somebody opens a PR on my site. Now maybe it's some Uber coder who's created something completely fabulous, and we're going to want that. Or maybe it's somebody who wasn't part of how the code evolved and what the priorities were for that repository 4 years ago, who's now suggesting something that's 4 years old that was decided against. So it's kind of this trade-off, and it turned out we thought that was a good idea. And on its surface it is, and I still maintain that it is, but it actually creates bias. We are biased against large repositories, like TensorFlow, for instance. The larger the repository, it turns out that they have many more open to closed than open to merged PRs. Okay, so that bias is there. We know it, but that was still pretty surprising to us when you had smaller repos that had higher responsiveness scores than some of these big ones. Okay, so that's repository recommendations, or responsiveness. All right, now, here's the exciting part, is that I've shown you what we've done. You can get back in there and tweak the weights, whatever, but you actually can create the same thing yourself. Okay, don't let us do it for you when you can go and try this out yourself. So there is this great web page. This is not owned by GitHub. These guys have gone off and done their own thing, and gals, called GitHub Archive, gharchive.org. And they provide open access to all of our data through the GraphQL interface that we have with our data. So you can go to their website, and you can get into some real crazy wget lines and go pull down the data, and that's fun. Or it's also on Google BigQuery if you prefer that. So let's go through an example. We're gonna create our own repository recommendation engine right now. Now I'm not going to actually do this in real time because I think I'm getting really close to the limit of my free credits on BigQuery, but. And by the way, always let it tell you this query is going to cost you X number of gigabytes to run. That's really good information before you rack up a bill. Things discovered the hard way. Okay, so here's the sample problem that we're going to do. Now, we can't walk through all of those different metrics, but let's just say we're going to look at me as a user on GitHub. I'm CJ2001, and we're going to look at finding other repos based on what I watched in 1 month. So I picked December 2017 just for fun. And what repos did I watch during December 2017? Okay, so I've got just a really nice, happy, easy SQL statement here that I put into BigQuery, and I got some results. And here's the results I got, and I'm sure it's very difficult to read, but these are just everything that I watched in the month of December. And I'm going to pick on one. I'm going to pick on SciPy. Okay, so I watched SciPy in the month of December 2017. I don't really know why it took me that long to watch the repo, but it did. Okay, so that's great. Now, what are we going to do with that? Somehow I want recommendations based on the fact that I watched SciPy. So what are those going to be? Well, who else watched SciPy in the month of December? Well, it turns out that there were 111 other people. So 112 including me. Okay, and this is what I run on Google BigQuery to get that. So that's cool, and here's a subset of those users. And you actually have to tell it select distinct because for some reason some users appear multiple times. Maybe they watch it, unwatch it, and watch it again. Not really sure. Okay, but I've got a whole bunch of users here. You can see me kind of in the midst here. Great, okay. So now I've got users who watched the same thing I watched when I watched it. And that time sequencing is actually probably important. Okay, because maybe I watched SciPy, and then I said, oh, now there's this other thing called TensorFlow. So I went from SciPy to TensorFlow. Okay, so the sequencing of what our users do is important too. Sequencing in their page views, sequencing in what they watch. And you're going to hear a talk tomorrow by one of my colleagues, Hamel, who's actually going to talk in detail about those sequence-to-sequence models. It's what we use, but I just don't have enough time to go through how it works here. And I know lunch, and I'm that speaker before lunch, which is always a really precarious position. But, okay, so we use sequence-to-sequence modeling here. So I've got my list of users. That's great. But now what? What are we going to do with that? Well, maybe I can look at, well, what other repos, those 111 other people, what else did they watch? Okay, so there's my SQL that does that. And I can come up with, those other 111 people watched about 3,800 other repos. Okay, so that's a big list, and I'm going to need to curate that list somehow, but just my manual curation, looking at this, there's things in here that make sense, that would make sense to recommend to me. Like if we knew that I was like, a machine learning person, it might make sense to recommend something like Cython or HBase, and I've got Boto3 down here. So we have to start bringing in other information. At GitHub, we've kind of decided what we think that other information should be, but that's from our perspective. You guys can write your own, and I recommend you do it. Play around with this data. It's out there. The GitHub archive people are doing a great job with it. So you can create your own recommendations based on what's important to you. How can you go off and take this data, or, this is just watch events. You could take who's following whom, or who's starred what. Or even just, what did I look at 3 years ago on this site, and do I want to return to that? So you can go and you can create your own recommendation engines this way, just with all of this open source data. Open source, meaning we're not showing you private repositories, we're not showing you hidden users. Okay, so what I might do with this, I would look at overlap between my watches and those 111 other people. Recommend things that they're watching that I'm not. But again, those sequences are really cool when you start looking at the time evolution of a person on a site like GitHub. How do I take somebody who's a student, maybe they're in Python 101, okay? How do they evolve on our site to become some really awesome machine learning coder? Maybe we know that, oh, this person has a desire to be an ML person. We should get in front of them TensorFlow. But TensorFlow is complicated. We don't want to get TensorFlow in front of them before they've really gotten comfortable with things like Python. And maybe we introduce Keras to them because we know that they're learning all of this stuff. Okay, all right, so that's enough on that. I'm just going to wrap it up here. I know that there's a lot of students and a lot of new ML practitioners in the room, so I thought I'd end with some suggestions for how to really, some general takeaways for how can you use this knowledge to benefit you. First off, before beginning, you have to ask yourself, what is the goal of the model? Okay, that's the thing that I've been hitting on kind of throughout here. You don't just go create models for the sake of creating models. I mean, that's really fun. And I'm a geek, so I do really find that fun. But what is this model trying to solve? We had a nice goal. And it wasn't just having that goal. We had to work in this context with product. We had to work with the engineering people. How was this all going to come together? The other thing I would point out is, yes, this GitHub archive data is really good. But at least 75% of the job of a data scientist is actually being a data janitor. You have to clean so much data. And what are you doing when you've got like, nulls or nada numbers or missing data? There's a lot of data cleaning that we just didn't even talk about at all in here, but is what you spend most of your time on is prepping the data before a model. The modeling comes at the very end. As sad as that might sound, the really cool math stuff, and I agree with the previous speaker that the math stuff is very cool, but until your data is prepped and ready and you have the right data to go into a model, the model isn't going to help you. So it's all about finding that right point to bring machine learning into the thing. Okay, and then the basic machine learning methods versus newer methods. I mentioned before random forests. Okay, that's probably not the most glorious algorithm out there. Every year seems to have its new favorite algorithm. We had XGBoost was winning everything on Kaggle for a while, and now everybody's going down the deep learning and the neural network path. But random forest it was quick, it was simple, and it got us a great answer. So we saw logistic regression earlier. Is that, some really exciting newfangled? No, but it works. So, think about trying those simple algorithms before you go hitting on those really crazy, complicated neural networks and deep learning approaches. It will save you time. It truly will. All right, so I am now at the very end of my talk. I would like to thank you guys for sticking it out with me through lunch. I know that's hard, but thank you, and thank you again to the organizers for the opportunity to present today.